All right, everybody, we have made it to our remote day. I am recording this in the evening, so I'm not 100% sure what the weather's going to do in the morning. I guess we'll find out. We're going to talk today about heat exchange and how heating something up can cause objects to expand, and how cooling things off can cause a lot of objects to contract. A lot of this should be very familiar to us because as we looked at the molecules of a solid, say ice, and we added heat to it, those molecules did expand and they got further apart and it turned into a liquid. And then that same thing with that liquid, when we cooled it off, when we took enough heat energy away, those molecules came close enough together, they contracted enough to turn back into ice. So these are things that we've already discussed. We're just going to get a little bit deeper into how heat can affect the way objects behave when you add heat and take heat away. So again, I just said this, when we add heat to something, it's all about the molecules, and we definitely need to focus on that. And when you think about how, when something is heated up, how those molecules are gaining that heat energy, and as they gain that heat energy, those molecules are moving further and further apart the more heat energy that they gain. One thing I don't like about hate being at home and not in class is, like, I'm sitting at my desk literally with my hands together, adding heat and moving my hands further apart, simulating the molecules. I like to do that because it gives me a visual, and that's why I like to be in class. But again, one of the things that you may not have really understood, and you'll get to understand it now, is how thermometers work. So when you have thermometers and you have that red solution that's in them, the molecules are kind of just sitting there, and the more heat you add, the further and further those molecules spread out, and so you have a higher temperature. And the colder it gets, the closer and closer and the more contracted those molecules get, and so you're going to have that lower temperature on a thermometer. So it's something that we've looked at, that we've used, and it's kind of amazing to think about all of the things that we go about our daily lives that are affected by adding heat and taking heat away, and the thermometer is one of them. You may be familiar with this, you may not. I see a lot of these when I am near the coast on bridges. You're going to see these gaps on bridges, and this built for a very specific reason. The engineers that have built those have put those in there to allow the bridge, when it does gain a lot of heat in the summertime, to expand. And so you'll see that these gaps would be much, much closer in the summertime. In the wintertime, it's also going to allow for contraction, and so you can see how these are a little bit further apart. So engineers, when they are building things, they have to take into account, especially if it's something that's going to be affected by a gaining of a lot of heat or a loss of a lot of heat, the contraction and expansion that something can go through. So they have to plan for that as they go through that. Railroads are a huge one. Those long metal beams of a railroad track, they need to have gaps in them. Otherwise, if you don't and they get too hot, you can see here this railroad has bent. You can see how much it has shifted the railroad track. And let's be honest, if you take a look at this train here and this buckled railway, that's not going to be a very fun thing to go across, and that could easily cause a train to derail. And so when they're building train tracks, they have to build that with that in mind. They do often paint some of these things with a lighter color sometimes in places that have a lot of sunshine and heat, so that it can reflect some of that light, and the train tracks don't go through as much thermal expansion. Again, I've already explained this. I'm not going to sit here and reread everything that I've already said. You're welcome to pause that and go through it if you need to. But again, it's just talking about how when you are an engineer and you're designing train tracks, you do have to keep thermal expansion and contraction in mind. We went through this about how thermometers work already. Again, not going to repeat something that I've already said. There's just a slide there for you to reference back if you happen to need it later on today. The opposite of expansion is contraction, or getting smaller, and objects contract when they are cold. And so when an object's temperature gets colder, the molecules, they move less rapidly and they get a little bit closer. As I was reading up and getting ready for this evening, I found something new that I had never really paid much attention to. And it said that the power lines outside go through thermal expansion and contraction, and that makes sense because objects go through that. And it said in the summertime you might notice that the power lines hang lower, and that in the wintertime they're a little bit more taut, they're a little tighter, they don't hang as low, because even they go through thermal expansion and contraction. And that's something that I want to start paying attention to as I'm driving down the road and I see these power lines on the side of the road. They're everywhere. I just want to look and see, are they lower in the summertime? Are they a little bit more droopy because they are longer in the summertime than in the wintertime? These next few days when it's going to be cold will be a good time to kind of take a look at it, and maybe we can go outside and take some pictures of some of the power lines near the school, and then we'll go back out at the end of the year and we'll see if they're a little bit lower. It'd be something that's very interesting to do, like a small experiment with. But again, when things are cold, they contract. So again, we mentioned this. These are those same spaces that can expand and get much closer in the summertime on bridges. They can contract and get a little bit further apart. And again, if you're building it, you're not going to build it where there's going to be a giant gap that's going to cause a car or a truck or something to wreck. You're going to build it with just enough space so it can move back and forth and things can still drive over it safely. Already talked about how thermometers work. Again, here's just another one of those slides that's repeating things. And again, if we're repeating things like train tracks and thermometers over and over and over, that just tends to be one of the things that I see very often on the tests, and I want you to really understand how those things work. This video I'll have to play when we're in class, because obviously I can't play YouTube videos inside of my video. That would be a copyright violation, and I don't want to do that. Water is very odd. We know for 100% fact that when you heat up water, the molecules expand and they get further apart, and it turns from a liquid into a gas. The very odd thing about water is that when water is cooled, it also expands. And that is because of the very intricate way that water molecules are formed. And when they contract and they come together, it leaves like this space in between them. And so, oddly enough, ice is less dense than water. And we talked about density and how much stuff is inside of something. And so that's why ice floats on the water, is because of those little spaces and gaps in between the molecules when they try to squeeze together. But then that brings about a problem. If water expands when it freezes, that can cause some major issues. Because if you were to get water, let's say in cracks in a sidewalk, and it freezes, well, it's going to expand. That's going to make those cracks even larger. If you were to put a glass of water in your freezer, well, the water is going to freeze inside of that glass and it's going to expand. Well, that would break the glass. In houses, this is extremely important because as water is going through the pipes to all the different parts of the house, at times like this, when it gets cold, sometimes people's pipes freeze. And that would mean that the water in the pipe freezes and it expands, and that's going to break the pipes in your house. And that can be a very messy and very costly and very troublesome event to happen. I've had it happen at my house before. So you might have people that leave their water faucets dripping. Have that explained to me by someone. I was like, well, listen, if the water's just running, is it going to freeze? The water that is coming out of the ground into our homes is going to be above 32 degrees, obviously, because it's not frozen, and it's going to continue to stay that temperature because of where it's coming from, so it helps keep your pipes from freezing at night, which is kind of an interesting thing to think about. If you have very well insulated pipes, which we will get to conductors and insulators, pretty soon. That is something where heat can move through things very easily, or if you're insulated, heat and cold do not move through something easily. So if something is insulated, you can keep it warmer for a lot longer. So most people have insulation around their pipes in their homes to keep the pipes above 32 degrees. Again, this is just these next few slides and the video that's on here. We will watch that in class on Monday. It's just a very detailed explanation of how and why water molecules form the way that they do. This is a very cool video that I will get to when we get back into class. And again, they kind of draw out the molecules of water and show you what it looks like when we get to that. And this last page is going to about convection, which we will get to when we talk about weather. I'm going to put up the notes for you. Obviously, I do not have to pause on my end. Once I put them up, you're welcome to pause the videos for as long as you need to take the notes. And after this, you will get on to Google Classroom. You will see your assignment. The assignment will be pretty easy, just a very quick check to see if you kind of understood what we talked about today, and then we will pick up with everything on Monday. I certainly will miss you guys today. I hope you have a wonderful time off. Enjoy your day. Finish your science, finish your ELA, finish your math, and those of you that have missing work, this is a great opportunity to make all those things up. Smash the like button and subscribe. We will see you on Monday.